Okay, next Tuesday we're going to take our second assessment on this in addition to the video you just watched. So, again, what you need to do on this roots and radicals, remember you take each one 3 times, and if your average comes to 90 out of the 3 assessments at the end, then you can lock it. So I see a 3 out here, so if there's not a power out here, then 1 goes in the numerator, but any root can be written as an actual power when you use a fraction. So I'm going to use a 3 on top, and then the root's index is a 4, so that is actually 5 to the 3/4 power. Okay, now with operations and multiplication, you simplify using a 1, a 2, and a 3-step process. So the first step is you multiply your outside coefficients 2 by 3, and that's 6. And then we have 4th roots, so I make a root with a 4 in the index, and then I multiply 162 by 3. That gives me 486. Okay, but I'm not done. You can't just stop there. So now what you need to do is see what, on step 2, see what on your list 486 is divisible by. So it's a 4th root, so I want to try these numbers here. Divide those numbers into the 486. So I divide by 256. Well, that doesn't work. I divide by 81. That does work. Okay. So I drop my 6 down, and then I make this into 2 4th roots. Okay, so 81 is what I divided by. We want to put that in the first root, and then the answer I got was 6. We put that in the second. Now the 4th root of 81 is replaced with 3. Okay, and then that allows me then to multiply the 6 by the 3, which is 18. So 18 with a 4th root over 6. Okay, now my next problem, this is different. Addition's much different than multiplication. You don't do the 1, 2, 3. You need to come up with a table. And what your job is to come up with the same number underneath these roots. Right now you have 135 and a 40. That doesn't work when you're adding, okay? So on one side you put 3 with a cubed root of 135, and on the other side you put the 2 multiplied by the cubed root of 40. So now you try dividing perfect cubes into 135. So you want to be on your cube list, and 135 would be, I'd start with 125. That doesn't work. Then by 64, which doesn't work. Then by 27, and that works, okay? So I drop my coefficient 3 times the 2 cubed roots, 2 different cubed roots, and in those cubed roots we want to put 27 times 27 and 5. So the cubed root of 27 is replaced with 3, and that 3 gets multiplied by the 3 that's already there originally, so that's 9 with a cubed root of 5. Okay. Now over here we try to divide the perfect cubes into 40. So 40 is probably not going to be divisible by 27. So by 8, you bet. So I drop the coefficient 2, and then times the 2 cubed roots and go 8 and 5. So the cubed root of 8 becomes 2, and then we multiply the 2 by 2, which is 4, cubed root 5. Now I have successfully done this so I have the same number under the root. So I want to put a 5 there, and then I add the 9 to the 4, and that's 13. Okay, now with variables, you want to separate the coefficient, the square root of 108, the square root of x to the 7th, the square root of y to the 5th, and then the square root of z to the 8th. Okay. So we're on perfect squares, so we want to divide perfect squares into 108. So that's these numbers here, the first list. So 108, it doesn't divide by 100. Is it divisible by 81? Nope. Is it divisible by 64? Nope. How about 49? Nope. How about 36? Yup. By the way, you want to make a cube right here because some stuff's coming out here. So you make your 2 roots, both square roots, and you put the 36 and the 3. So we put 36 and 3. But we always replace the first root with its equal of 6, because that's why you divide by that. So you're going to put a 6 outside and a 3 inside. So x to the 7th means there's 7 x's, and we want to pair them by 2. So 1, 2, 3. So that's 3 pairs. So we put x to the 3rd outside and x inside. Okay, y to the 5th is 5 y's multiplied together, but we're going to group them by 2's, and that's a y to the 2nd because there's 2 pairs, and then a y left over inside the root. And then z to the 8th would be 8 z's. That's 4 pairs with none left, so z to the 4th out here, and I don't have a z inside. Okay, there we go. Okay, so we can put this to the side. We don't need it till we do the graphing part, because the next part we're solving equations. So if I see a root in the equation, okay, I know the end game's to use a second power to lift it. Now look at your root here, okay? Is there anything outside the root that you need to worry about? Because 2x plus 1's inside. You don't have anything in front. You don't have a plus or minus outside. So we're ready right now to get rid of our square root. And we always do that by taking both sides to the second power, okay? Because the square root and the second power undo that side, and I have 2x plus 1. Now on the other side, 7 to the 2nd is 49, and then I can easily solve this. I subtract 1, that's 48, so 2 times x equals 48. And I divide by 2, and x is 24. Now that's the only answer. Some of you are like, well, since it's a square root, would there be 2 answers? No, that's a rule you use for powers. You don't use that as a rule when there's a root there. Okay, my next one, here's my root. Okay, I got some things going on outside, though, before I do the second power. First, we have to check for any addition or subtraction to undo. So first, we have the plus 6. We're going to need to undo that first. You want to always undo the plus minus first. So that takes that side to negative 22. And then I have negative 2 multiplied by x minus 3. Now, I still have this negative 2 as a multiplier outside, so I need to divide by negative 2. And negative 22 divided by negative 2 takes that side to 11. So I have the square root of x minus 3. Now I have got rid of all the operations outside the root, so now I can do my second power. So second, get rid of it, and 11 to the 2nd. So we have just x minus 3, and then 11 to the 2nd power is 121. And all you got to do is add 3. So there's only one answer. 124. Again, negative 124 is not an answer. That's what you do if there would be a second power in the equation. Now, I did do a second power, but it wasn't in the original. I had to use that to undo the root. Okay, my next problem. I see I have x to the 4th power only. So that means there's 2 answers, because now I have an actual power. Okay, it's even, so 2 answers. So first we have to undo the 3 by dividing by 3 before I worry about the power. So x to the 4th equals 100. And then to get rid of any whole power, we make a root. And remember to put the correct number in the index, because just a square root is not going to do the job. So I go 4, and then second, and then the upside down V button. So that tells me I want a 4th root instead of a square root of 100. And I get 3.16, and then the other solution would be negative. Okay, now my next problem, I have x plus x to the 4th, but there's a plus 2 with it. Okay, so I'm going to want to use my q to simplify the equation. Now, the 4th power is even, so there's 2 solutions for that x. So I'm going to want to use my q to simplify this. And then I'm going to want to make my table so I remember to bring back my x plus 2. And I need both sides of the table because there's 2 answers. So I add 1, that's 81. To undo that whole power, we take the root out of both sides, and we're going to be doing a 4th root. So 4, second, upside down V81, and that's 3. So again, you could be at 3 or negative 3 because the power I canceled out was even. So I'm minus 2, I get 1 for my first solution for x. And negative 3 minus 2 is negative 5 is my second. Okay, my next problem. I see I've got x to an actual power. It's a 4/3 power. That's really crappy writing. It looks like it's 4/5, but it's actually 4/3. Now the 4 is the actual power, and that's even, so it tells me, okay, there's two answers. So before I worry about the power, I have to undo the multiplication of 7 by dividing by 7. Now 175 divided by 7 is 25, so x to the 4/3 power equals 25. Now, if the power is a fraction, we're not going to make a root. We're just going to take this to the 3/4 power and take the other side to the 3/4 power. You just reciprocate the power. So 25 to the power, okay, of 3ABC4, that gives me 11.18. So I could get 11.18 or negative 11.18. Now, the worst part is, the worst problem on the whole thing is this, okay? Now, I see we're back to having a root, so I don't really have any operations outside the root. So I go right to my second power to get rid of the root. But I don't have just a number here. I have a binomial to the second, so we know what happens here. This side, I'll just have the 9 times x, but over here, I'm going to have a trinomial, blank x squared plus blank x plus blank. Now, to find out what goes in there, we need to go to our scratch paper and duplicate our x minus 10 times our x minus 10, okay? And use the 1, 2 to simplify. So first, I take 1x times 1x, 1x times negative 10, negative 10 times 1x, and negative 10 times negative 10, the FOIL method. So it's 1x to the second, negative 10x, negative 10x, and positive 100. Okay, now I have my trinomial because I got 1x to the second. If I add negative 20 times plus negative 10 plus negative 10, that's negative 20, and then I have 100. So I've got 1, negative 20, and 100. Now we'll do the GCFT, but first this 9x has to be cleared. You've got to have it equal to 0 before you go to the factoring, and that goes with my negative 20x. So that's 1x second. Now again, if you don't put 11, it's negative 20 minus 9, which takes us to negative 29. So minus 29x plus 100 equals 0. And now I know what my trinomial is for sure. So greatest common factor, it's just 1, so we don't really need to worry about that. And then my t-table. So ABC, so I take the a times the c, 1 times 100, that's 100 positive. So we're doing a sum, we're adding to get 29. Now remember, our 29 is negative, okay? Eventually, if you divide 100 by 4, you get 25. You'd fail till you get to that, but you do eventually get it to work. 29 is negative, that means 25 is negative for sure, and when I have a positive up there with a sum, the signs have to be the same. So minus. A is 1, so I just need 2 parentheses with x times x, since the x is just to the second power, and then minus 4 minus 25. So there's going to be 2 answers because I have 2 factors involving x that equals 0. So x minus 4 could equal 0, or x minus 25 could equal 0. So I plus 4, so 4 is my first answer. And add 25. 25 is my second. So watch out for that one. If you have a root and you do a second, but over here there's a variable, you're probably going to have a trinomial, and you're going to need to do the factoring. It's a lot easier if there's just a number by itself over there instead of a binomial expression. Okay, now just multiply these expressions out. Now again, anytime I'm multiplying with roots, I want numbers in front. That 4 would not be in front. Okay, there's a plus sign there, and that would be a 1. Okay, so I distribute 4 to 4. I go back to 4, 4 to negative 1, but the negative 1 needs the square root of 3 connected to it. And then 1 to 4, but again, the 1 needs the square root of 3 connected to it. And then 1 to negative 1, but both of those need their square roots of 3 connected to them. Okay, so 4 times 4 is 16. 4 times negative 1 is negative 4 with a square root of 3. And then 1 times 4 is 4, and we just put square root of 3. Now, these are identical products, but one's negative, one's positive, so that means they can be canceled. And then 1 times negative 1 is negative 1. Then I open up a square root and I multiply 3 by 3, which is 9. Now don't just leave that because 9's on the board. That's a perfect square. That turns into 3. And then 3 is multiplied by negative 1, which is negative 3. Now you plus those. 16 plus negative 3 is 13. Don't multiply them, you add them. Okay. All right, now over here with the i's, same idea, 5 times 5. Look from parentheses to parentheses. 5 times negative 2i. 2i times 5. And then 2i times negative 2i. So this is 25, negative 10i, positive 10i. Okay, I got identical products, but one's negative, one's positive, so those can be canceled. That's negative 4i to the second, but we know I to the second can be replaced with my negative 1. Then multiply negative 1 by negative 4, that ends up as 4. Then we add those because those are obviously like terms, and that gives me 29. You should end up with just one integer at the end of these because you're multiplying conjugates, okay? They're the same factor, but one's positive, one's negative. Okay, now the graphing, I did not explain this very well. I kind of had you doing funky stuff on your calculator. So don't put the 2 there if it's not there. Just it's a square root, so you're going to pick your perfect squares, okay? If there's a 3 there, I'd go 1, 8, 27, but it's a square, so 1, 4, 9. Don't put the 2 there. Just trust me here. So 1, 4, 9, and we'll go with the negatives. Now we want to box off the origin, okay? Now, I'm making this way too confusing on the calculator. Just hit negative 2, and then hit second, and just hit x to the second, okay? Hit second, and then just your x to the second. Since it's just a square root, we can just go with that, okay? Now, I can't enter these in yet because I have to undo the plus 3 to all of these values. Because if I take 9 plus 3 and get 12, bad things are going to happen because 12 is not a perfect square. So that's going to give me 6, 1, negative 2, negative 3, negative 4, negative 7, negative 12, okay? So again, this is all I really need right now. So I'm going to go 6 plus 3, and then plus 8. You don't need to do that 2 second caret and all that. Just negative 2 second x squared, and then the root pops up. Since this is a regular square root, we just go with that. Now, if you want to do it in your head, 6 plus 3 is 9, but the square root of 9 is 3. 3 times negative 2 is negative 6, plus 8 is going to be 2. Okay, then I just hit the up key and just replace your 6 with 1. Okay, 4. Now, when I'm doing negatives, again, negative 2, just hit second and then the x to the second power button because it's just a square root. If it's a cube root, I'd go times 3 caret 2, but it's not. So negative 2 plus 3 and then plus 8. It's going to be 6. Your y-intercept, okay, negative 3 is 8. Okay, then hit up and then 4. Okay, you got a domain error, and the reason you get one is because negative 4 plus 3 starts giving you negatives in the square root, so we delete that. Now we want to again graph that point first and write stop. So go left 3, up 1, 2, 3, 4, 5, 6, 7, 8. So write stop right there because any point beyond there you won't have because all these x values lead to negatives. Negative 2, 6, left 2, 1, 2, 3, 4, 5, 6, and then connect. 1, 4, so 1, 1, 2, 3, 4, connect. And then negative, and then 6, 2. So 1, 2, 3, 4, 5, 6, 1, 2, and then connect. Now I can keep going this way forever, okay? Because I did 1, 4, 9, but I could have done 16, 25, 36. As long as it would be positive, okay, it would work.